Okay, so let's see what happens when the denominator factors, but the factors are not distinct. So in this example, the factors in the denominator are x minus 1 and x plus 1, but x minus 1 appears twice because I've got it squared. Okay? So the setup is a little different in this case. But before I do that, let's notice that the degree in the numerator is 4 and the degree of the denominator is 3. So we must start by doing long division. Okay? So, so this denominator is x minus 1 times x minus 1 times x plus 1. So x minus 1 times x squared minus 1. So that's x cubed minus x squared minus x plus 1. So I would need to divide x to the fourth minus 2x squared plus 4x plus 1 by x cubed minus x squared minus x plus 1. And x cubed goes into x to the fourth x times. I multiply x by x cubed, and then by minus x squared, and by minus x squared, and then by 1. Let's see, so x to the fourth minus, yeah, that seems right. And then I would subtract, right? And the x to the fourths cancel. I get minus a minus x cubed, so x cubed, minus 2x squared plus x squared, so minus x squared. 4x minus x is 3x, and then the 1 comes down as well. And then x cubed goes into x cubed once, so 1 times x cubed, 1 times minus x squared, 1 times minus x, 1 times 1. And then we subtract, and the x cubes cancel. We get minus x squared. I guess the x squareds also cancel. Get 3x plus x, so 4x. And then 1 minus 1, the 1's cancel. So we just have 4x. And so this original expression can be written as x plus 1 plus 4x, that's a remainder, over x minus 1 squared times x plus 1 dx. Okay. And the integral of x plus 1 is easy. That's just 1/2 x squared plus x. So we just have to do that fraction, that rational expression. So we want to look at 4x over x minus 1 squared times x plus 1 and decompose it into its partial fractions. So if I didn't have the x minus 1 squared, I would set it up as a over x plus 1 plus b over x minus 1. But because the x minus 1 is squared, it's slightly different. So for the x plus 1, it's the same type of term. For the x minus 1 squared, I'm going to get two terms, b over x minus 1, and another one that's c over x minus 1 squared. And if it had been x minus 1 cubed, I'd get a d over x minus 1 cubed. Okay, so I get, because it's squared, I get two factors in my decomposition, two fractions, one with x minus 1 to the 1 and one with x minus 1 to the 2. Okay, so you just have to know what the decomposition looks like. Otherwise, when you try to find your ABC, you're not going to be able to do it. So the process for finding A, B, and C is the same. I'm just going to take this equation and multiply both sides by the denominator. So I'm going to get 4x over x minus 1 squared times x plus 1 multiplied by x minus 1 squared times x plus 1. And that is equal to a over x plus 1 times x minus 1 squared times x plus 1 plus b over x minus 1 times x minus 1 squared times x plus 1 plus c over x minus 1 squared times x minus 1 squared times x plus 1. Okay. Then we cancel, so the whole thing cancels over here, and x plus 1 cancels there. One of the x minus 1's cancels for the b term, and both x minus 1's cancel for the c term. So I'm going to end up with 4x on the left-hand side, a times x minus 1 squared, plus b times x minus 1 times x plus 1, and then c times x plus 1. And again, a good strategy is to plug in values of x that simplify that equation. So I can see that if x equals 1, I'm going to get 4 on the left. Then the a term is 0, the b term is 0, and the c term is 2c. So c is 2. And if I let x be minus 1, then I get minus 4 on the left, and I get minus 1, so 4a. And then the b term is 0 and the c term is 0, so a is minus 1. And at this point, we don't really have any other nice values of x to plug in, but we could just do one that maybe isn't quite as nice. So x equals 0 is usually a good choice. So if I let x be 0, I would get 0 in the left-hand side, and I would get a minus b plus c. But I know that a is minus 1 and c is 2, so this would give me 1 minus b, and so that means b is 1. Okay, so then the integral of, what did we have? X plus 1 plus, right, so I had x plus 1 plus 4x over that denominator. And the 4x over that denominator, I've now written as a, which is minus 1 over x plus 1, plus b, which is 1 over x minus 1, plus c, which is, 2 over x minus 1 squared. And that's going to be what? 1/2 x squared for the integral of x plus for the integral of 1, and then minus the natural log of the absolute value of x plus 1, plus the natural log of x minus 1. And then the last one is really a power rule, right? If you let u be x minus 1, it's really the integral of 2u to the minus 2, right? So, so over here, the integral of 2 over x minus 1 squared is the integral of 2u to the minus 2 du, where I've let u be x minus 1. And so that's just our power rule, so it's minus 2u to the minus 1, plus c. So this is going to be minus 2 over x minus 1 plus c, and so that would be our final answer. Okay, now I invite you to try to work out this example before you look at my solution. So pause the video and try and work it out, and then come back and see if your solution agrees with my solution. Okay, so 7x squared minus x minus 2. The denominator I can factor out in x squared. So 2x plus 2. Yeah. Okay. And so there are two linear factors, x and 2x plus 2, but x appears twice. So I'm going to have an a over x and a b over x squared to represent the x squared. And then since 2x plus 2 is only there once, I want c over 2x plus 2. Okay, so I multiply everything through by x squared times 2x plus 2, and I'm going to get 7x squared minus x minus 2 on the left, and I'm going to get ax 2x plus 2 plus b times 2x plus 2 plus c x squared. And if I let x be 0, that would give me minus 2 is 2b. And if I let x equal minus 1, I would get 8 minus 2, 6 equals 0 plus 0 plus c. So b here is minus 1, right? And c is 6. And then I'll just say x equals 1. And then 7 minus 1 is 6, minus 2 is 4. Is that right? Minus 6, yeah. And then get a times 4 plus b times 4 plus c. And I know b is minus 1, so this is minus 4, and c is 6. So this is 4a plus 2. So, so 6 is 4a, and a then is 3/2. So, so this is going to be the integral of 3/2 over x plus, no, minus 1 over x squared plus, what's c? c is 6. 6 over 2x plus 2 dx, which is 3/2 log x, and then 1 over x squared, that's an x to the minus 2, so the integral is x to the minus 1, so plus x to the minus 1, and then plus 3 log of 2x plus 2 plus c. So that should be the answer that you should have gotten. Sorry, I think I made a mistake here. So over here, 4 minus 2 is 2, right? So a should actually be 1/2. And so this should be 1/2, and this should be 1/2.